So right now we have Ramesh Ramani from Tavant speaking. The next speakers will be Ramanath and Nilesh from Mindtree.
So good afternoon, folks. I'm Ramesh Ramani from Tavant Technologies. I'm here to share our experience with model-based testing on the open source world. Quickly, as all of you, we've also been using combination testing tools in testing web pages, reducing the few thousand tests into 100 tests and being benefited out of it. We just felt, why can't we use it in the in testing models? So our first experience was trying to build, like I just took a quick example of licensing of one of our application in terms of language product and things like that. Every model needs condition to be put. That's a place where we have took the first cut. Then what we have done is we went ahead, looked into various tools. We identified a tool called Jenny. It's a very good tool. The only challenge being it communicates or it gives the input and output in the orthogonal fashion, which is not very easy to understand. So actually, I've built a tool called JRAP and also published in sourceforge.net, where now you can see where you can give these yellows like Japanese, Chinese, and full text search would not go hand in hand. So meaning a condition can be put in and you would be able to use it. So problem one solved. And the next thing what we also realized is towards how we would be able to efficiently use this tool. I'm sure all of us would have read this software testing a craftsman's approach, where we talk about weak normal equivalence class partitioning, which predominantly helps us to reduce the number of tests, but still try to keep at least one test covered at a time. So we use the same approach, use this model, where you could see there are two tests we could be able to use from the same model. One which could be used for functional testing, where it's an exhaustive number of tests. The another set, which is a very, very small, concise number, which can be used for smoke and doing some kind of a patch release and things like that. When we saw this benefit, one of our team member came and said, I think that there was a question today morning also, I'm not able to associate results, and every time when I execute this, we have a challenge in terms of filling all the results again. So what we have done is we have put our results also with the model, not like an elaborate result, but a simple pass-fail, where now we are saying Japanese, Chinese, full text, and it will not go with pass. So it has to fail. So we achieved two benefits. One, probable results is also given to user, point number one. Point number two, we also covered a lot of negative tests which were not covered as a part of your previous tests. And the nice thing about it is, as someone said in the morning also, where there are a lot of conditions which we would have not thought about, which comes out of this, where you find all these issues in the requirement phase rather than finding it in the testing case of oh, with this, what is the result? So that helped us in terms of improving our productivity. And the best thing is it allowed us to sell this whole idea to our test engineers as well as our managers. Once we have done this extensive work, we just realized that we need to add a lot of conditions and to make the model really work. And we felt JRAP was not scaling up completely. So we used PICT from Microsoft. It's another tool which allows us to do a model-based test, where we have given quite a lot of conditions there. Probably you can see it. And the nice thing is, when we have started scaling up, our business analysts have also become more shrewd. And they said, look, we need these kind of conditions to be added in our tests. So we came out with the idea of adding seeds to it, where the seeds are the combinations which are mandatory conditions which you want to add. So we added these seeds and we were able to generate these models. By this way, what we have achieved is one, we are able to completely cover the model. We are able to get the results. We are able to increase the productivity, as well as we were able to kind of find the challenges or not having proper expected results upfront. So to summarize, our experience in the model-based tests shows that it's going to be a challenge in terms of trying to bring the whole model into the tool. But the best piece out of it is it improves your productivity, it improves your quality, and using open sources like Allpairs, JRAP, and PICT also saves a lot of cost, and it helps you in terms of time and again proving your managers that there is a better return of investment on this tool. Thank you so much, folks. Thanks for this time.
So next we'll have Ramanath and Nilesh from Mindtree. After them, Redzwan from Mimos will be speaking.
Hello, good afternoon. I know you guys had a good lunch, so we have been told that quickly finish our talk without disturbing your sleep. So we'll try to maintain that. So the talk we are going to is on achieving testability in performance testing. I'll probably take 30 seconds and give it over to Nilesh because I told him that I will give him the full time to talk because I already recorded and put it on YouTube, so you can look for this title and you should be able to see a video recording of our session, which has much more details and things like that. I would like to give you a gist of things, what we're going to talk about, then let Nilesh take over. So what we have seen over the last couple of days is a lot of different aspects, right? One is we saw tools, we talked about certain methodologies, we talked about certain best practices, we talked about various things, right? So this talk is primarily to bring it all together, right? So we know that each of them, right, are powerful in their own. When you take tools, tools are powerful. You take about methodologies, they are powerful. You take about the expertise that people bring in. Of course, we are smart, we are powerful, right? So, but when you bring it all together, the amount of power you get in this whole thing is amazing. So we're trying to cover that aspect in our talk, right? So I'll give it to Nilesh and maybe come later if we have any points to add.
Yeah. Good afternoon, everyone. So as Ramnath rightly pointed out, there are many aspects that brings testability to many to the testing activities. And tools, methodologies, people expertise, they kind of contribute to that. And so when it comes to tools, there are, we have seen, a lot of focus has been shifted towards using open source tools these days. But, using open source tools has its own challenges, and because they have their own limitations. And in order to bring, overcome those limitations, we have to take some measures to, or do, we have to do something extra to be able to effectively use those tools, because open source tools, they are good at what they do. They are good with doing one activity. Let's take an example of JMeter, which is an open source load generation tool. It is good when it comes to generating load, but it lacks certain capabilities like distributed execution, reporting, etc. So we need something extra to bring the testability or bring down the effort of performance testing while using open source tools. Like in addition to that, we would require certain helpers also to kind of deliver under the pressure and bring down the time aspect of it. Then because in performance testing is very critical to get the things first right at the first time, because performance testing in most of the cases is an afterthought, that when product is about to release, we are given the product that we are releasing in 2 weeks, please do performance testing so that we can make sure that we can release the product. So often there is a pressure to get the things right at the first time. So that adds up to the pressure on the performance testers. So and there are customers or as users, we are kind of now are less patient as compared to our earlier days. Now we want something to be appear on our screen within microseconds. So we have to manage that end user expectation also while carrying out performance testing. So as Ramnath pointed out, we have to kind of do a mix and match of 4 major components to kind of bring testability to performance testing. That is to bring down the total effort required, the time required for doing performance testing. And first of it is a methodology. Kind of step. So methodology. When I say methodology, there are 2 aspects to methodology in my mind. One is a step-by-step kind of guide or a roadmap as to how I'll go about doing performance testing, because if you miss a thing in performance testing, and the kind of impact that it will have on overall performance testing effort will be huge as compared to the functional testing, right? So having a roadmap as to a step-by-step guide as to how you will carry out performance testing is important. Second is the knowledge base, and as to how you will perform each of the step. The second is frameworks. Since, as I mentioned, open source tools have their own limitations, we have to kind of build frameworks around those open source tools to achieve, to carry out those end-to-end activities, right? The third is accelerators. You need accelerators in order to kind of save some time. For example, JMeter. JMeter doesn't have a very good debugging capability. So while debugging a script, you may end up spending a lot of time. So having some kind of accelerator to easily debug JMeter scripts will certainly help a performance tester. And lastly, expertise. So expertise is in using all these things. You need to have people who are kind of good, because performance testing demands a lot. You need to know databases, you need to know how a web server works, how to monitor them, how to analyze the results, and stuff like that. So having that expertise is also very critical. So when this comes together, certainly the time and effort will go down, and the value it will bring to performance testing will certainly go up. Thank you very much.
Thank you.
Thanks. It's a challenging schedule. So Red Suan from Mimos is speaking now, and after him, Tanli from Aconex. But you don't have slides.
No. Title is a bit weird, but that's actually the false positive that I always get whenever I execute the usability testing. At the end of the usability testing cycle, I ask the participants during the debriefing, and they always say everything's fine, there's no problem. So there's something wrong in the way that we or myself conduct the usability testing. For example, one of the techniques that I use is the think aloud. Well, initially when they are executing the usability testing using the web application, they'll say things out loud, whatever that they think. But after half an hour, they'll be thinking of going back, so it's not going to be loud anymore. Then we use the Likert scale. And people tend to put everything at the middle because it's easier for them. And we had some success using eye tracking, video recording, and audio recording to try to analyze the behavior. But all that costs a lot of time. And the psychological part of it is users going to get tired, they get uncomfortable and everything when we call them to the lab to conduct the usability testing. So the key point here is if you can minimize direct human interaction, you can actually have a better or maximize the usability effectiveness during your usability testing. So I'm looking at, right now, crowdsourcing for usability. Why don't we do that? We minimize the interaction, but we get a lot of users to do the usability testing for us. For example, minus all the tools that I have in the market today, I have something in mind. Maybe we can use the spy tools, the tools that you use to maybe to track your spouse or your kids' internet connectivity. You can use that to do the usability testing. Of course, the privacy part will have to be dealt with later. This tool can actually do a keyboard logging, the coordinates, the mouse movement, and the mouse clicking and everything. And with this kind of information, and you have thousands and thousands of users accessing your web application, it can actually consolidate all this information. We have a parser at the end of the server to consolidate all this information, and we can actually build an effective heat map for every single page of your web application. So it's a good way, in my opinion, to measure the effectiveness, efficiency, and user satisfaction, the key areas in the usability measurement. So that's it. Thank you very much.
Speaking, and after him will be Vasilis Rizopoulos from Tsilke.
Okay, hi guys, how are you guys going today? Good. Okay, so today I have an opportunity to talk about behavioural-driven development using JBehav WebDriver and sharing the story that the team is doing in Aconex with your guys. Traditionally, the way we develop in software is that we're moving, requirement process actually moving from outside in, and implementation actually moving from the inside out. So we often end up with a product that having gaps. And behaviour is only validated for the end of the development lifecycle. And we end up with the product is not meeting the requirements at the start. So it's interesting to see that there are no more coding, the coders going, requirements thrown in out the door, and coder just pick it up and coding in a cave and just throw out the product at the very end. It's very collaborative now in a more of an agile environment. So talking about BED, it's a term coined by a guy called Dan North from ThoughtWorks, and the principle is very simple. It's all about behaviour. So we encourage all the team players actually using the same language, the same linguistic to define the behaviour of the system throughout the software development lifecycle. And the other principle is enough is enough. So upfront planning is often having diminishing return. So we need to develop those requirements that we go on and finding areas or mistakes to improve rather than having a bunch of requirements upfront that never leave and die throughout the development lifecycle. Deliver stakeholders value. So the fact that we have this business value embedded in the test case itself. So the story, written in plain English, and we use JBehav to actually hook it up to the actual implementation on the back end. So do given, when, then. So annotation provided by JBehav to do all that. Behind the scene will be a bunch of pay objects, what we call, and also UI control widgets allow us to do certain things with our customized widgets. And WebDriver used to drive the tools there as well. So a typical story will be looking like this, exactly what the English speaker normally do. Well, the BA also, the tester, actually get into a room and decide whether that is the feature that we're moving forward. So this scenario actually acted as acceptance criteria, and it living throughout the development process. So we pick it up and we develop test. So you can see here that we have a bunch of annotation given. We map the English text with the actual test need to be run. And you make note here that we develop a stay machine here that asks colleague on the new mail page. So we set them to stay and then we expect what is behaviour driven at the very end. The test has been readable by mostly the QA and developer. And at the same time as well, it's the given reports been written in English as well. So you see those clause here, highlighting green or red if it fails or if it passes as well. So just to wrap it up, so why it really matter? Because actually provides with only one source of truth. So we end up with just this documentation living throughout the development lifecycle. Less code is better. So we write these before writing the implementation. So we end up with better, cleaner style at the very end. Embrace quality mindset across the whole team. So the fact that we have ownership of these documentation at the start to the end, and everybody actually agree on that, is helping to embrace quality mindset. Okay, so that will be the end for my talk. So thanks.
Great, I love it. People get to the point, to what's important. We've got Vasilis Rizopoulos from Tsulke, and after him will be Himanshu Agrawal.
Hi guys, I'm Vasilis. I work for Tsulke. It's a Swiss company. Some of the guys working for the Zurich office might know it. This is a metaphor about my way here. You guys and me, we live in different worlds. Now, in the beginning, there was code. It was only code, and the code was in text files. So what we did, we had a lot of code, we packed it in zip files, we lugged it around, put it in a case, and we moved about in crutches and shared it. Now, if you get a picture of people with floppy disks running around and sharing zip files, you're wrong. That happened to me a month and a half ago. After this, we put version control in it. Okay, it was a bit better. We got to lug a bit more code around, but it still wouldn't allow us to test, wouldn't allow us to do pretty things. We got to figure out who changed what and when, but it took quite a bit of work. So what did we do? We added BS, well, a build system. Now, that made things a bit better. We got to get more code, we got to get a bit easier, we get to move around faster, but still, getting to test the whole thing was, go pick the build, bring it off, figure out which environment to run it on. It still was hard. So in that metaphor timeline, for about 60 to 70 years, we started making these things a bit faster, a bit nicer, and we added continuous integration. Now, everybody knows what car that is? Huh? That's a DeLorean. There's a reason for it. Now, continuous integration continuous integration gave us the time, essentially, to test and start talking about the things we're talking in this GTAC. Start thinking about how to test better, how to scale, how to perform better, how to do testability discussions, and start thinking about how to improve our tools, which brings us, and that's where the DeLorean is, to the future. Now, the future is what we need to do here. Improve our tools. Well, actually, guys, you need to improve the tools. Okay, you need to figure the best processes. I live in a different world. I live back where the rickety cart was. Okay, so please make the tools, make the processes, teach them, and give them to me so I can live a bit better. Thank you.
I think, you created a monster.
One thing, I need to refer to something. The talk is actually stolen. The Are We There Yet? The Are We There Yet is a talk by Rick Hickey. If you type it in and you go to InfoQ, there's a talk about Rick Hickey talking about time and how we manage it in programming languages. Some excellent ideas and some excellent concepts in there. So I had to give credit to you.
Thank you very much. I think if we go by the clapping meter, that would probably be the best talk we'll hear today, but we'll see. So next is Himanshu Agrawal, HCL, and after him will be Kunal Banerjee, also HCL.
Good afternoon, everybody. So the topic says environmental intelligence. We must be wondering what is this all about related to testing. Think of testing as an ecosystem, and how does environment plays a role in the testing parlance. So I take this opportunity to leverage whatever we have seen in our past experiences and touch upon briefly some of the ideas that we are trying to develop from a solution perspective from here. So let's consider a scenario where a set of change requests are slated for release, and a release is being planned. A product manager worries about, is the release going to be successful? Am I going to meet the customer expectation? Is my development time going to be well under time and cost? Whereas your developer, when he faces with the issues or the bugs, he says that, oh, it was working fine for me earlier. What has suddenly gone wrong? How do I fix it when I cannot reproduce it? A typical scenario where the defects are not reproducible, where the tester is saying, for the new release, how do I plan? What has changed? What has impacted? And how do I ensure that my release, I have tested it thoroughly so that my release goes very well in the production? Right? And from end user perspective, if we see that he is worried about with the new release coming in, where there is going to be any stability issue, is he going to get the same performance as he was earlier, or the change functionality is going to deliver to his expectation, his or her expectations. So we thought that looking at these scenarios, when we think of a testing as an ecosystem, it is just not about testing of the code. It is about how do you look at the ecosystem, how your customer is using the product, how is he voicing his feedback through various social networking channels, or how he is leveraging other means to communicate, like service help desk for enterprise products and things like that. And whereas, if you look at the other parlance, so broadly speaking, we see that environment can be broadly divided into two portions. One will be, like if you know your environment well, your environment is basically your development environment, the environment which you are using for building the products. And the customer environment, know your customer environment is basically dealing about how the customer is using your product. Think of AAs where we are not talking of only web applications or desktop applications, we are talking of mobility as an area and things like that. So the ecosystem itself is too large to deal with. So looking at a scenario, the current scenario that I described, what we are saying is that if we can have the ability to look at your environment in terms of having a bidirectional traceability, and we have successfully kind of conceptualized and implemented a concept called binary analysis based on which we are able to, on the fly, even the source code is not with there, we can do that. And looking at other parameters like how do I do the impact analysis with minimal time on it, how accurate it is from that perspective, how do I find out the code coverage or even the functional coverage to speak of, and how do I accurately publish the release notes out of it. So this is only one portion of the environment, know your environment. There are other thought process we are also trying to build upon. Know your customer would definitely look at something like, how do I capture the scenario? Supposingly a deferred system crash has occurred. How do I have the ability to capture the snapshot of the system when it has crashed and make it available to the dev and the test team to actually run a fix simulation and the fix onto it. It greatly helps them to actually see the scenario for themselves and simulate it in their dev and test environment. Here we are trying to make use of our virtual test lab, where we are also having some capabilities around P2V and V2P, virtual to physical and physical to virtual images replication. And that gives us the ability to come up with capabilities to replicate the environment. And lastly, the ability to provide an integrated analytic view across the social network, your customer environment, your dev and integrated environment, help us to give early feedback right from the requirement phase to the development phase. Thank you.
Thank you. Now we have Kunal Banerjee, and after him will be Mike Davis.
Hi, everybody. Can you hear me? Yes. Hi, everybody. I'm Kunal Banerjee. I'm from HCL. I'm representing an idea which we as Accelerate are presently working on. The concept engineering out of the box. Mostly we'll find that as developers, as testers, we are in a box. We keep to our task. We do what we know the best. Engineering out of the box is a concept wherein we think out of the box. We are changing the rules of the game. The first and the most important thing, it's a service company. We service our end clients who further on have their set of clients for whom they are asking us to develop a certain product or application. Engineering out of the box, first initial concept is, do not think about your client. Think about your end user. Think about his per se. What does he want? Think about the standards. Think of the business implications, what your business end user has. So in the traditional world, we used to think like this. We normally, what are non-functional requirements? I'll just cover before that. There are two sets of requirements. Functional requirements, which are specified in any requirement document, which I have to create, which I have to work on. It has always been a focus area, all since throughout the ages. The second part is non-functional requirement. These are things which have not been specified anywhere. These, we consider them as good to have. Earlier we had functionality and user interface used to be in the functional requirement. A well-documented area, we have a set process flow, everything was working fine there. There might be some slippages, but they were well documented, and certain actions were taken against it. The second part was good to have. Performance, security, all these came in this aspect. What this led to is, post-development of a functional requirement, we used to then sit down and think, okay, now let's see what the performance of this application is. If my client accepts that, benchmark it, send it. But today's world is very different. Today, as you might see, the performance security have moved from the good-to-haves to the must-haves. Now it is no longer a good-to-have feature for the client. For the end user, these are the most important factors on which to decide whether to go for this application or the other application. Now, in the good-to-have, we have got certain new features, like self-healing. So we would now be focusing on, these are the normal. Earlier, we used to have a very small, it's not SDLC, it's the reduced form of SDLC. For we used to have a requirement analysis. We used to do designing and modeling on those functional requirements. We used to think of how to implement it. We used to test it. That was our earlier. With the change, oh, it's not visible. Okay. The top level is non-functional requirements, and again, the same cycle is being repeated. So what I intend to cover here is, for each and every non-functional requirement, we require to analyze it. We require to design and model it. We require to implement it as well as test it. I'll give you a scenario. Earlier, in the earlier days, we used to have clients, business managers of client, who used to give the request for proposals, RFPs and bids. Today, we find technical people involved there. We find consulting firms who are involved, who ensure that such kind of NFRs are documented. In our design phase, what I suggest is we analyze, we think for the end output of, say, 5 seconds to display a page, what should my internal each component be, what is the time required for that? Break that up into module-wise requirement. Then in the implementation phase, let the developer know what is the constraint, what is the top level mark, so that he can implement it in the same way. Testing phase, very important. Start the testing early. This is what testability is all about, according to me. Thank you.
Next, we'll have Mike Davis, and after him will be Philip Sembra. Click that. Good.
Okay, hi. My name is Mike Davis. I'm an SET in the London office, and I'm here today to give you a quick introduction to CrawlJax. What is CrawlJax? So, CrawlJax is an open source research tool developed by the University of Delft. I have to make it quite clear, it's not a Google tool. But over the past year or so, a few of us at Google have worked very closely with the team in Delft to take this research and apply it to some real-world web apps. And today, I want to share my experiences of using the tool and give you a quick demo of what it can do. So, what is CrawlJax? CrawlJax is an automated tool for helping with end-to-end web app testing. So, traditionally, when we do end-to-end testing, we think about scenario-based testing. We define scenarios, workflows through the application, and we use tools like WebDriver and Selenium to automate them. Then we assert things on the page, and we go about it like this. CrawlJax takes a slightly different approach. It's an automation layer built on top of WebDriver. So rather than doing scenario-based testing, it automatically analyzes the pages, identifies what is clickable, and explores the app itself, doing a depth-first traversal to find all the possible states. So I think the best way to show it is with a quick demo, which may or may not work, given that warning we just had. So this is the test. It's written in pure Java, so it integrates with all your standard Java tools like JUnit and this. You can't really read that, but that's pretty much the whole test. We define, we give it a web app to test. Here it's Google image search. We give it a little bit of guidance as to what to click. So we say click all anchor tags and click all buttons. We give it a little bit of restriction. We restrict it to just google.com, otherwise it will follow the image links through and try to map the whole internet, which is probably not a good idea. And we've put a couple of limitations in because this is a demo and we don't want it to go on forever. So let's see if this plays. Oop. How do I play it? Ah, looks like it's not going to play. No. Oh well, if it played, you would see it fires up WebDriver, because it's built just on top of WebDriver, and it would do a depth-first traversal of the Google page. It would click all the links, goes through, finds the images, clicks on the images, and then at the end, it will produce you a nice state graph showing all the possible states for your application. That's CrawlJack. As I said, it's not a Google tool. It's developed by the research team in Delft. But obviously, that's just a crawler. It's giving you a nice, pretty state graph of your app. But the thing that we're really interested in is how you can use this to add testability, right? How can you add value to your test suite using this sort of tool? And this is where the collaboration with Google has been working. So the first thing we did is we started experimenting with very simple, like page invariants, things you might have on every page that you wouldn't necessarily check with your WebDriver tests. Perhaps you've got headers and footers. You want to make sure they're on every page. So you can write a very simple plugin. Every time it finds a new page, check the headers and footers. Perhaps you've got help links. Perhaps you want to make sure that you never see the error page that says an engineer has been called. Tests like this are very simple. And because you don't have to define your scenarios, it should hopefully require less maintenance than traditional WebDriver scenario-based testing. Other stuff we've experimented with doing is things like cross-browser testing. Certainly, the developers all use Firefox. So in Firefox, the app is pretty good. So we can crawl it with Firefox. Then we can take this explored and derived state graph, and we can replay it through all the other browsers and test whether or not we see the same things, whether we see errors when we load it in IE. And that's proved quite effective. We've also looked at doing things like load testing, performance testing, the fighting layout bugs that Michael Tam presented at GTAC last year. You can write a plugin to do that in 2 lines and run fighting layout bugs over every page of your UI. That's quite nice, I think. So, yeah, this is CrawlJack. So it's not our tool. It's written by University of Delft. If anybody thinks they can use it to add value, I highly recommend to give it a go. And, yeah, this is an open research problem. So if you do give it a go, I just ask that you let them know, give them your feedback, give them your experiences. They're doing a great job to sort of try and solve our testing problems. And I think we should try and support these people. And as the same with the university earlier. Like if we're building the sort of DeLorean from Back to the Future, they're setting out trying to build the flying train from the 3rd one. So we should try and help them with that. Thank you.
Next will be Philip Sembra, and after him is Narayan Raman. Narayan, you still want to give your talk? Yeah? Okay, he'll be after.
Hello, I'm Philip Zemrud. I'm an SET, software engineer and test in the Stockholm office, and I want to talk about test as specification. And I'm focusing on automated tests here. Of course, automated tests as specification is nothing new. That's standard test-driven development lore. But if you've ever, like I usually do, started reviewing code by reading the tests, then you probably have found that some tests work very well as specification. They help you understand the code. It's very nice. And other tests do that less well or not at all. And I like to call these tests well-specifying tests and poorly specifying tests. The latter, in my experience, are typically tests which are heavy on mocks, heavy on mock expectations, and they are often pretty much like a plaster cast of the implementation. So for every call in the method that you test, you will find an expectation, a mock expectation in the test. And what this test in effect does, it locks in the current implementation, says this method is supposed to be implemented like it is right now, and if it is not, that's a bug. These tests are not very useful in my opinion, and not really a proper specification. Well, why should you care? You could or are quite likely to run into some problems with these tests. For example, just the plain simple, what the heck is this test actually testing? Or this test is failing. Is that serious? This code is actually tested, but frankly, we still don't really know how it works, how it behaves. Very unpleasant. And last not least, I refactored this module. Now I have to rewrite all the tests. That's a real pain. Yeah, and by the way, where's your safety net for the refactoring? Are there any tests that are still valid? Or are you free flying and hope that it works afterwards, after you locked the new implementation in place? On the other hand, if your tests are well specifying, there's a couple of benefits you can get there. And the two I find most interesting ones are well specifying tests tend to be more robust. If your test clearly specifies what it is testing, and everybody agrees, yes, the code we have, the module, needs to pass this condition. This is a must, it's a specification, it's a requirement. Then it's quite likely that after you change the code, this test will still be valid, no test change will be necessary or even acceptable. And the other point is, well-specifying tests have more authority. So this situation I just sketched, test fails and you don't really know what it does, and you're considering ignoring the failure, then you're sort of you may start to ignore the test loses authority, you might ignore it, and you might even be right. What the test is doing might be totally irrelevant to what you're actually achieving. And so the better specifying a test is, the more authority it has. So where you want to be is, what does this module do? Look at the tests. It's written quite plainly. This test is failing. Is it serious? Oh, absolutely. If this one doesn't pass, if we don't have this property, no way are we going to ship this. You need to fix this corner case. And very pleasant for a programmer. Hey, I refactored this module. It looks much nicer now. Cool. Are you sure you didn't break anything? Yeah, tests all pass. Coverage is good. I'm quite confident. Didn't have to change a single test. That's where you want to be. And based on this, I had this idea of an authority rank for tests. On a scale from 0.0, you can safely ignore this test when it fails. In other words, better throw it away. To 1.0, this test, there's no way around this test. If it fails, no way are you going to ship this code. And what one could do with this then is weight coverage metric with this. Code covered by high authority tests, code covered by high authority tests could then be considered well covered as well. And code covered by poorly specifying tests, not well covered at all. This is, of course, in line with what Sebastian told us yesterday. Thank you very much.
So next we have Narayan Raman, and after him will be Rahul Verma.
Hello everyone. My name is Narayan Raman. I'm the author of Sahi, another web application testing tool. What I'm going to speak about today is better object identification for web applications. One of the things that has been kind of prevalent right now is that identification of objects on the web should always happen through XPaths or IDs or some other names. So it has been actually, over the last 2-3 years, XPaths have been considered to be kind of the right thing to do. So before that, let me just take a quick check. How many of you do web application testing? Okay, and how many of you use XPaths for the testing? And if you do not have IDs and if you do not have XPaths, what do you actually recommend to do? Add IDs to those objects. And if you do not have control over that, what do you do? Any answers? So you mean that an application is not testable if it doesn't have IDs and if the XPath is complex. right? So the thing is, if we were to actually use XPath to, let's say, get up to this board right now, you would actually start from the top, like go to this, come here, third, fourth box, and then here. But really, what you could actually do is to say that, like, get to this particular board near Narayan Raman, right? If you actually had APIs which did that, which said that, okay, get to the text box near that username. So that would be a much better way of actually defining your test. And the thing is, when you say that, like, a text box is near that username in a list of users, then what happens is that, like, even if you actually put in a column in between, or like you add something else in between, there is nothing that changes in the test really. All you're doing is saying that, okay, one thing relative to the other, and the other is actually something fixed as far as the business logic is concerned. So likewise, if you were to say that, okay, there is a checkbox which is actually near this user, which says, there are two checkboxes near a user. One says delete, one says edit, let's say. So if you had to actually define this, you should be able to say, okay, look for the checkbox near the user under delete or under edit. If you have APIs like that, you don't have to actually resort to IDs or to XPaths. And what I'm talking about is not something that is like kind of theoretical. This is how Sahi implements all accesses, and it also has a recorder which actually lets you do all this. So the thing is, the amount of time people actually waste in XPaths and going back to the developer to add IDs to that, if they just actually used APIs like these, they would have a much better time. So that's it. Thank you very much.
Next we'll have Rahul Verma.
Hi, good afternoon. Here I am again after yesterday's lightning talk. So you guys had rejected my talk if you haven't realized so far. So what I've done is I have split my talk into 5-minute chunks, named them subtly, so that I can pass them on to you in the form of lightning talks. Anyways, so this topic is on the design of automation framework in such a way that it could be used for performance testing. So when we talk of early performance testing, early performance engineering, one challenge which we face is identification of performance critical scenarios. We depend on usually the dev team or the testers who have knowledge about internals of the code to give us such scenarios. And most of the time, it has remained in books. The only book which has been written on the subject is, I guess, Performance Solutions by Connie Lloyd. There was no one who dared to write on performance engineering on non-web stuff or non-client server stuff. That is a challenge which we face. In the name of dearth of resources and time, performance engineering in desktop or SDK applications is usually not done. So what we can do is, you can use your functional tests as performance indicators, the automated functional tests, okay? Even if you have performance testing practice, engineering in place, still your automated functional tests can be very, very good performance indicators. So what you have to do is, if you are using multiple frameworks, you have to build a meta framework around them. Provide the provision for passing on a Boolean switch which says, okay, now you have to log performance statistics. These are the metrics which you have to collect, and these are the number of iterations. Number of iterations is a key element, especially in desktop applications, because the response time or the operations are in decimal places. You could have time unit in microseconds, milliseconds. So you have to have statistically equivalent data. For that, you would need multiple iterations for your functional tests. Now, data is there. What would you do with that? Do you treat it as absolute performance data, or do you treat it as comparative or heuristic performance data? That would depend on your context. 2 hints which I can give to you is, if it is a client-server application, there is a concept of probing client. Okay, some people, what they do is, while the performance testing is in progress, your virtual users, you have a big lab, what they usually do is, they put a manual tester who exercises the web application while the main performance testing is going on. Now, this experience of virtual users would be averaged, or at the most, there would be a percentile taken, statistical analysis would be done. But this probing client, the manual tester, or a set of manual testers, would be providing to you the absolute experience of a user when your application is on high load. Okay, so you could use your complete functional testing, including unit testing, white box tests, your system tests, as the probing client to give you absolute performance experience. Second essential thing is that in the design of performance tests, you are usually caught with workload distribution pattern, assigning weights, types of users, and although Scott Barber Alberto, these guys have been suggesting that you should include error scenarios in your performance tests. We hardly do that. But in your functional tests, you have those paths covered. So at least in your probing client experience, you would have the error scenarios covered, and resource utilization peaks are usually observed in such scenarios. So functional tests can be very, very useful performance indicators. It's just a matter of time that we realize that. What I'm saying is beyond JUnit, instead of JUnit, you use JUnit perf. I'm not saying that because there's a limited use to that. You have to develop a meta framework. Either you have to do it from scratch, or you can build a framework around your existing stuff, which is the suggested option. Thanks for your patience.
We actually could take one more lightning talk if someone wants to do something spontaneously. Any takers? Rahul wants to do a third. Shall we say yes?
Okay, here goes the third part. So a similar challenge which we face in the field of test automation is, there was a related topic as well, test prioritization. In the theoretical field, we deal it with risk-based approach and rated stuff. So what we can do for an existing framework, okay, the solutions which I'm suggesting, they can be employed on whatever framework you're doing, okay. So what you can do is, for a regression framework to become auto-regression framework, a framework which at runtime realizes what all tests it has to run based on the areas impacted. Okay, simple solution. You start with a high-level activity, then you can model it down. Okay, so what you do is you split your complete application functionality into a set of logical labels. Okay, for example, feature underscore one underscore whatever. Okay, now you have logical labels. It is a list of strings. What you have to do is, in your each test, you subscribe to these labels. Okay? Each test could subscribe to one or more labels, so that it knows that whenever I am passed the configuration, I have to check that, okay, these are the labels which have been passed to me. Maybe a bug was fixed, or maybe a code change was made, and so I should run. Okay? Now, what you have to do simply is, you have the labels in place, you have the tests and the registration in place. When you configure a test cycle, you just pass on the logical labels. That these are the labels, and whatever tests subscribe to these labels should run. Now, this is a very easy solution to implement in any existing framework. Okay? You can start with a high level, maybe come up with 20 labels. Slowly, you can keep making sub-levels of them, and you would see your regression testing framework becoming an auto-regression testing framework. Thank you.